Hey there, CS210 students. So in this recording, we're going to go through the introduction of objects in C++. Now, from your previous programming classes, definitely the Java class, maybe the Python class, you would have been introduced to creating objects and classes in those courses. And here, we're going to reintroduce those ideas and then how to do it in C++. Now, in object-oriented programming, the crux of it is creating objects, the first O in OOP. The big idea about objects is that you can represent anything. Now, sometimes we get really hung up on we need to model some concrete object. So for instance, maybe we're trying to, model a chair or a couch or a drawer. Those are physical, tangible things. But we could actually have anything that just encapsulates data. So like they say here, an object is a grouping of data and then operations that can be performed on that data. So in real world programming, we might have a manager class that is handling, database access. Anything that we want to encapsulate all functionality for, we would write a class for. So let's scroll down here a little bit. As we go through the sections in this recording, it's going to deal a lot with a restaurant. So what are some things that a restaurant might have? Well, it's going to have a name and a phone number. It's going to have cuisines, dishes that it serves. It's going to have reviews, um, all sorts of things that a restaurant might have. So one of our first tasks in creating objects is to simply identify what data do we need to encapsulate. So we kind of get that idea going here. And again, the idea that I just kind of mentioned here earlier is the fact that with a class, we want to abstract or wrap encase the data that we are handling. And then through proper object-oriented programming principles, we can encapsulate and hide particular details from users of our class. And we'll see that as we get going in the next couple sections. Okay, so in C++, we define a class with the name of it, and then we have open and closed curlies here. So again, the class, we could have public functions that are available to any instance of that particular object. So here you can see that they've got the public keyword followed by a colon, and then these are the method definitions that this class is going to have. So it would have a set name, a set rating, some kind of print method. These are the methods that are available to this class, and they are public, which means we can declare a variable of type restaurant. So right here, we're declaring a variable of type restaurant. And then when I use the dot operator, so inside an IDE like Visual Studio, when I use the dot operator, I'm going to see the public members that this class has. So when I do fave place dot set name, I will see it, and then I put in the name of the restaurant there. Dot set rating takes an integer value. So again, I will see that because it's public. Same thing here, print method is public, so I will see those methods in the IntelliSense of the class. Anytime you're not seeing something when you hit the dot operator, that means one, it either is not defined, or two, it's not declared public. Now, we'll talk more about this here in a bit in our recording here, but public is only things that you want to expose to everybody. Typically, variables are going to be private, and inner operations inside the class that you don't want to expose the details of are going to be private as well. And then anything that is available outside is public. Again, I just kind of went over that. So again, we can declare variables. We can use the dot operator. We can see here we've got a favorite lunch place. It's getting a name and a rating. We've got a favorite dinner place variable. It's getting a name and a rating. And then we can come out here and print those methods. Okay, so let's go to the next section. So defining a class, again, I just kind of alluded to this a second ago. Not only can we have public members, but we can have private data members. So we can have fields in this class called name and rating. We could have then coming down here if I try to access that rating variable, you can see that this is red, stricken out. That means it would not be accessible. So if you tried to do this, rating as a private variable, you can't access it. You could potentially set the rating using this set method here, but you can't directly set it right here. So 99% of the time, you're going to make your fields of the class be private, and then you're going to provide public methods to interact with the data. Okay, so back in the last chapter for chapter 5 with functions, we learned how we could create a function declaration and then implement it elsewhere. So classes support that idea as well, where we're going to declare our class, we're going to provide function declarations. So this is just simply saying, hey, this class is going to have a function called fct1. It's void, it doesn't take any parameters. And then eventually, somewhere, we have to implement that method. So you can see here, they've implemented the method. And in order to do so, you have to use the name of the class and then the double colon operator. That's referred to as the scope resolution operator. And that's saying, all right, you need to go to the my class, and it's got a function called fct1. Yep, got it, right there it is. And here's what it's going to do. So whatever functionality we would want that function to do gets written right here. So again, kind of continuing on with the idea, we've got the restaurant class here. We've got the same methods that we had before, and then we come down here, and if we want to implement that method, we go void set name. That's the name of it. And again, you have to use the scope resolution operator and then fully implement that method. And oh, by the way, Visual Studio will help you out with this. So let's just come in here, we'll paste that. I have to put an include up here. Let me get that all taken care of. I'll be right back. Okay, so I've added the includes up here. So we'll come down here and I can let Visual Studio help me implement the definition of this method. So I'm just going to click. I'm going to click right here, promote to document, and it has inserted in the stub of this method. So now we have that implementation taken care of for us. And you can see here that they're then making the name equal to restaurant name. So name, it knows, hey, I am the restaurant. I have a name. And it can assign it there. If I try to do something like name2, it's going to say, well, there is no such thing as name2 because it's not defined up there. So I can only work with the things that are defined. And you can see that they've implemented the other methods as well. Okay, let's go to the next section. And in here, they talk about what are called inline member functions. What these are the actual implementations of a function in the header file. So for instance, they initially said, all right, this class has a method called function1, and then eventually got implemented. Here, they're going to actually implement that method in the header. This should only be done if it's something very trivial, something very, very simple like this, where they're initializing num a equal to 0. Now, that doesn't make any sense really for this function, because you'll see later on that we're going to use a constructor to set the fields of this. But if you have something that would be very, very very, very trivial, then potentially you could do that. My word of advice is this: just don't even do it. It's pretty uncommon in industry to do this. It's more common to define it and then in a separate C++ file implement the functionality. But it is something you should be aware of because you might run across it at some point. And let me back up to one thing here. The reason that we define classes this way in C++ with the function definitions and then later on implementing the functionality in separate classes is it can speed up the compilation process. The C++ compiler looks at the header files and says, oh, yep, you've got this, and you've got these different attributes and methods and things, and it speeds up the compilation process. And in the linking process, it actually takes the C++ files, does its magic, and combines everything when it gets fully compiled. So that's why we do this. Okay, so let's define in our classes the idea of mutators and accessors. So mutators are going to be any function that's going to modify or change a value in a class. So we've had these set name method, set rating methods. These are mutators. They're going to change the value of the variable name, change the value of the variable rating. Oh, by the way, it's pretty uncommon to actually use setters in production code. Reason being is this lets you change the data of the object, and in a multi-threaded application, it's very possible that one thread gets changed, the other thread is expecting some results based on the previous state, and now they are completely different states. So in any kind of any kind of multi-threaded application, the setters are avoided, and you only go through the constructors, which are coming up shortly. So we had setters. Those are mutator functions. They change the values. An accessor, or just a getter function, gets a value back. So if we wanted to get the name, remember it was private, so we didn't have access to it. But now we can provide a getName method saying that it returns a string, and it's just simply going to return this variable name. So if I come down here, you can see here's the getName implementation. It's just simply returning the variable value of name. And likewise with getRating, it's going to return the value of rating. One thing that I do like about C++ is we can put the const keyword after this function here, and this makes it where you cannot change the data member. So it'll cause a compiler error if the function modifies a data member. So kind of a nice little guard preventing anybody from changing a value. Oh, by the way, as you're going through here, you see they're naming these functions with capital S's and G's and capital P's. In our code, unless it's Zybooks, you need to be using camel case, where these are lowercase, not uppercase. Again, I mentioned earlier, we can have public methods. We can have also private methods. So you can see here that they've declared a function X as a private member, and they have implemented it. But if I have an object of that class, and if I try to use that function, it is not going to be visible in IntelliSense. In fact, if I try to have it, it's going to be a compiler error. So if it's private, you can't use it. Why would you have a private method? You might have some kind of operation that does not need to be exposed, that is only going to be used by the class and not elsewhere. So I just mentioned in the last section that those setters should be avoided because we should do all of our initialization really through constructors. Now, C++, since C++ 11, it's required you to initialize variables, and any variable declared of that class type will have those initial values. So one thing you have to be careful with is if you don't initialize variables, it could be null in some cases, depending on the compiler. You may even get garbage values in some compiler situations where if it's not been initialized, you may get some random characters or whatever was left over from that previous memory location. So I'm not a big fan of doing anything like this right here, because what we should be doing is not using setters. We should be using constructors. So just like you learned in the Java class for sure, potentially in the Python class, the constructor is a method that is called every time a new instance of the class is created. So you can see in here, they've defined a constructor right here, and it's always named the exact same as the class. And for right now, they are defining the restaurant constructor, excuse me, implementing the restaurant constructor right here, and they're setting the name to no name and the rating to -1. Now, we'll see here in a bit where we can pass parameters to this constructor and then initialize the values with those particular values. Um, I definitely wouldn't want to do like no name or -1. I guess it's a nice, I can check if the rating's -1. That means, it hasn't been initialized. But ideally, the constructors should always set them. So here is, again, we could run this code right here. They're going to declare a variable called favorite lunch place. They are setting the name to Central Deli, setting the rating to 4. Well, if they didn't do that, okay, so if they didn't do that, the print method would have used right here the name, which would be no name, the rating, which is -1. So if I didn't do this, it would have these default values right here. So maybe in some cases, you know exactly what the default's always going to be, but typically you're going to provide parameters to the constructors. In 6.7, we talk about the fact that we can use vectors and classes together. So remember, a vector is a data structure to store objects of a similar type in a list-like structure. And in C++, to declare a vector, you have to give it a data type. So in the previous recording back in, I think it's chapter 4, we had vectors of type int or string. Well, now we can create our own classes and then have a vector of that particular type. And so review list, we can see down here that they are putting in a review. So they've created a review object right here. They're setting its rating and comment. So all of that's implemented up there. So the review object has a current rating, has a current comment, and it's getting put into a vector. So that's putting data into the vector. Here you can see that they're going to loop through, and here's the review list. So they're going to loop through the vector and they're going to grab the current review and get its comment and display it if it has one. So again, we know that -1 means that it has not been set. A vector could be a field in a class. So they have a class called reviews. So we could have a vector. Again, you can have any kind of data type you want as a field. This could have been a vector. It could have been an array. So any data type that you want to use. I think I'm going to kind of skip most of this. It's all kind of self-explanatory because we've already done all this. They're just having it inside of a class. Okay, last section that we're going to talk about in this part of the recording is, again, and we've already kind of seen this in chapter 5 where we worked with functions. We defined some functions in a header file and then we implemented them in a CPP file. So again, the idea here is that the .h file is always going to be read first when programs are compiled. And so this just simply defines what we have. So we've got a store item. It's going to have weight ounces. It's got a method called print. It's got a setter for that particular field. That's all it has. And then over in the CPP file, we're going to include the header file for store item. And then whatever else things that we might need. So here they're going to be doing some C out. So they just went ahead and using namespace std. So that brings in the whole standard library. IO stream, they're going to need that to handle some things here. So in the implementation file, we need all the things that are going to be used. And then we define, we've got set weight ounces. Here's the implementation. Remember, you have to reference it by the name of the class and the scope resolution operator, and then very similar with the print method right there. Then when I want to use storeitem.h, so like in the main method, we just include that header file. And so now we can use store item objects, we can set the weight, we can print it, and do all the things. So then they go through how could we create, the review, the restaurant implementations. And I do want to take the time real quick just to point out, so in Visual Studio, what we would do, if I right click, add class, we'll call it restaurant. Well, I'll go review. So did they call it review or reviews? They called it reviews. So I'm going to add a class called reviews. Excuse me. You can see that it's going to provide the header file and the CPP file for me. So I'm going to click OK. And it has the header file underneath the header files, and the source file has been added right here. So I can then just dump in whatever code I need into those two particular files. So that's the reviews class header, and there's the CPP implementation. Okay, so I'm going to wrap it up for this recording. In the next recording, we'll talk about some more details on using objects at kind of a little bit more advanced level.